Hello everyone, and welcome back to Reverse Engineering Linux 32-bit applications. In this video, we're going to continue our discussion of format strings. And in particular, we are going to talk about how we can view arbitrary memory locations. So in a previous video, we talked about how you could view things on the stack. And we want to extend that idea just a little bit in order to view things that are anywhere in memory, really. And we talked about memory protections in some previous videos, and we said when it comes to things like the stack, it's protected against execution, and we have different things that are readable and writable but not executable, or readable and executable but not writable. And we said that was really great, but notice, of course, everything is readable. So I can use a very simple technique in order to read any location in memory that I so choose. So let's go ahead and have a look at how this works. Now I'm going to go back to our simple example program. In the previous video, we went to a little bit more complicated program, and that's just more than we need to do. And so I'm going to go here and have a look at this program. So we'll start by running it up in EDB. And I will give it just a couple of simple parameters. Like so. Run it to my breakpoint. Do my normal analysis. And now what? Now what I would like to do is I would like to find an arbitrary string in this program. Now you'll notice that here it's pushing this location 80485110 onto the stack. So this is really 08048510 is how we would write this. So this is here in my user program, and this is a constant that's been set up that just says, this program is going to do various things. So I'm going to try and print out this particular string. And again, I can print out stuff from anywhere. So this shouldn't be that difficult at all. So that location is 0804 8510. Okay, so for my purposes, I'm just going to let this program run. And now I'm going to make a small change to what I'm going to pass into it. I will now pass this. I'm going to pass the value of 10, 85, 04, 08. So I'm going to pass this value in, and then I will once again have my 3% x's and then a %s. And we will see what this does. So let me run it. Run to my breakpoint. Do my analysis. Step away. And so what do I have? I have a couple of different values in my call to printf. So let me go ahead and make that call. I'm going to step into this. And it says my program exited normally. All right, so it printed out this value, which wasn't exactly what I was wanting. So why did it do this to me? Well, here's why it did this to me. It did this to me because I made a little mistake here, and I was confusing what I can do in the shell with what I can do in things like Python, for example. So let me back up for a second and actually enter this the right way. And once again, I did something bad. I put single quotes around this. So I might say, well, what happens if I just use double quotes? And I'm not going to bother to run this through EDB. I'm just going to run it. I want to see what happens. And here, once again, it merely printed out these values. In other words, the shell is not going to interpret those values the way that I wanted. If I had some characters that had these various ASCII values, I could do that, and that would be simple enough, but I don't. So I'm going to resort to using Python. Now, some people would actually use Perl here. You might not be familiar with Perl. It's a very old scripting language. Nothing wrong with it. But I think for our purposes, we will just go ahead and use Python instead. So I'm going to run Python 2, and I'm going to give it this command. I'm going to say, please print out this value. So Python 2-C, saying, here's my command. My command is just print this. And now it printed out something a little different. So we can say, what's going on here? Well, let's have a look. In this case, I will once again run this up in Evan's debugger. Run to my breakpoint. Step away. So now what do I have on my stack? On my stack, I have a few different items. I have a couple of addresses, etc. So let me call print f and here's my program. So my program has printed out a couple of values, but it doesn't seem like I got exactly what I wanted. So you might say, well, what's going on here? I was hoping to print out memory at this location 08048510, but that's not what I got. So I have 10850408. And now what? Well, let me go ahead and just continue this a few more times. And we will see what we get here. So we have a couple of different locations on our stack. First one is FFDF4217. And this is my call to print F. So right here I'm calling printf, and I'm going to give it this argument. So FFDF4217. And there I have the value of %x, 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 %x. So I seem to be a little bit off with my values. Now notice that here I have my 08, 04, 8510. So what happened? Why am I off just a little bit here? And that's a very interesting question. Because this was my address that I wanted to have. So I ended up just a little bit off. And here I have my output. All right, so we seem to be slightly off somehow. And how did this happen? So what is it that I'm trying to do? I'm trying to put this value on the stack. And as this string is being put into my program, it seems like I should be able to have that on the top of my stack and then later print it out. But my program is being a little bit problematic. Now I decided to make a couple of simple modifications to my program. I created a local variable, local stir, and I went ahead and I copied argv1 to that. You might say, why did I do that? I did this in order to get this value closer up to the top of the stack. And we'll see what this does here in a second. And then I'm just going to call printf on local stir. So let me go ahead and once again, I will run this in my debugger. Here's my memory location. I've given it 3 X's and a %s. Let me step to my breakpoint. Step forward. And now this location's actually changed. Now it's at 85E0. So that's a little update that I'll want to make. But we've got plenty of time for that. because we have a little bit more work to do here. Let me step forward. Here's my new stir copy that I added. And now I'm getting ready to call printf. So you'll notice that this is pointing to my string. So it's pointing to my string at a certain location. And that location is on the stack. So it's FF826B0C. Now, what I need to do is count how far down do I need to go here. So I've got this address. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11. And then item 12 is this address. So it looks like I have 8 things to print followed by my string. So let's think. Did I say 8? I think I meant 11 there. Let's go ahead and let it fly. See what it did. And it printed out a few different items. And it printed out a null because I didn't go far enough. Okay, so back here. We're getting closer to what we want. This seems an awful lot like things that we did back in the stack buffer overflow days, which seems like it was a long time ago. It was something like 10 hours ago, I think, in our video course here. So now I have this. Now I'm feeling lazy and I'm using Python. So I am going to do the following. I'm going to print this plus I'm going to print %x plus %s, and I'm going to say %x times 11. And we'll see how this looks. So if I hit my breakpoint and I start stepping, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12 is my address. So let's see if we calculated this correctly. So I'm just going to go ahead and let it fly again. And it looks like it was unhappy with me because I was 1 off. It was trying to go to this address. All right. Try 10. We will let it fly. And in this case, I didn't get an error. And it said it exited normally. And voila, success. So now I printed out a few of these items, and I also printed out the string. This program prints what the user inputs. All right, so it took us a little while to get there, but we eventually were able to print out an arbitrary address in memory. So the big thing that we had to do here is we had to figure out exactly where on the stack this would go to. Now, because it was a string like it was, it became a little bit more convenient to copy it to local variable. That put it much further up toward the top of the stack, which made this a little bit simpler. And of course, we did this just for convenience. I could have left it just the way that it was, and that would have had me going a little further down in the stack, and we could do a little experimentation to find that. And the reason for that is the compiler is smart enough to say, hey, that's argv1. That's a constant. That's something that was passed in when you started the program. There is absolutely no reason for me to make another copy of that on the stack. And that's what happens when you have a smart optimizing compiler. All right, so that shows you how I can read any memory location. Obviously, I could abuse this to read large chunks of memory, and you never know what you're going to find there, right? I might have passwords stored in memory. I might have decrypted keys stored in memory. So there's all kinds of things that I could pluck out of memory that would help me just completely violate this poor little program with its flaws. So that is how I can view an arbitrary memory location using a format string error. And that is pretty much all that I wanted to talk about in this video. As a reminder, this video is one in a whole family of videos and courses that we have here at Pen Tester Academy, your source for all things InfoSec. And I look forward to seeing you in this course or another course soon. See you then.